will finish tonight. Homework is due after the spring break, so you have plenty of time. We're going to talk about sequential switching today. So let's see, first we're going to do RC circuit. So let's say you have this example. This is not from test, this is somewhere else, something. Or it's one of the, not from the back in from the chapter, but earlier problems. So, but you'll see that it's going to be pretty useful for you when you do homework, okay? And the analysis will be pretty much the same like we did on Monday, so that's a good news. So you won't, if you know what we did on Monday, this won't be any surprise to you, you know. Pretty much the same thing. Okay, so for this circuit here, as you notice, there are two switches here. Okay? And that's why it's called sequential switching. Okay? You have switch one who is closed, that it's closed for a long period of time and opens up at t equals 0. And you have switch two that is open for a long time and then it's closed at 10 milliseconds. They ask you to calculate the voltage on capacitor for t between 0 and 10 milliseconds, and then voltage on the capacitor for t greater than 10 milliseconds. Okay? Piece of cake. Where's the slip knot guy?
The what knot guy?
Well, long hair slip knot guy?
Yeah.
Okay.
Enjoying the weather.
I'm not blaming. You're gonna get pounded one more time. This is too early, I think. That's how that goes around.
This is our fake spring.
Yeah, gonna pound us like 2 weeks.
We like it.
Or a week,
Yeah.
and then we'll get out of it. Something like that. All right, so analysis is pretty much the same. Well, a little bit of difference. So first we need to do, again, what's going on with the circuit from minus infinity until 0 minus. So it's gonna be, right, for a long time. This was closed, this was open. So your capacitor will be charged up, right? Until, you know, first switching happens, right? So t equals 0 minus, capacitor will be open and charged up, right? Whatever voltage you have, about 25 kilo ohms, that's your voltage on your You guys agree? Look, your circuit looks like this. That's what you have. So this is what you have, right? So basically, if you need the current to 25 kilo ohms. So basically, you need 25 kilo ohms, and you can do current divider, basically to calculate that current. It's going to be 40 kilo ohms divided by 40 plus 60 plus 35, right? Times 10 milliamps. It's going to be kilo, right? Kilo ohms, right? So basically, you can cancel that milli and kilo right here, and you're going to get, well, not really, no. This kilo, like that. So you have a 25 times 40 times 10 divided by 125, which gives you, that's 80 volts. This is what you get, okay? Right? So now, switch moves, right? So let's say for t when equals 0 plus, switch will move. That means that this switch one opens up, and then you're going to have circuit like this. For 10 milliseconds, right? They have this and this. At 25 kilo ohms, and you got here 1 microfarad. And you have plus minus VCT. So obviously, this is an NR, natural response, RC, right? For load. Okay. And then you can basically figure out tau. VC infinity is equal to 0, right? In this case. Tau is equal R Thevenin times C, which is basically just one resistor here, which gives you that Thevenin is equal 25 kilo ohms times 1 microfarad, which gives you 25 milliseconds, right? And that gives you that stop. Shit, stop. Right, so basically here now you can say that VC of t is equal VC of infinity plus VC0 plus minus VC of 50 times e to the minus t or tau, which will give you that that's equal. Let's mark this as a tau 1, because we're going to have another tau. So tau 1, that will give you that VC of t is equal 80, because this is 0, right? And that's 0. That's 80 volts. And tau is 25 milliseconds. That gives you that this is equal e to the minus 40t volts and this is the t between 0 and 10 milliseconds. So you can basically found solution to part A. Okay? Right? Any questions? So it's pretty much the same like what we did on Monday. And now you need to include a second switch. So for t greater than 10 milliseconds, then you have to include 10 kiloohms. So basically you have another natural response, right? Because then capacitor will discharge to 25 kiloohms and 10 kiloohms. So you need to find another. So for t greater than 10 milliseconds, right? Your circuit looks like this. You get this resistor, and a capacitor. We have another resistor right here, and that's basically 25 kiloohms here, and you got 100 kiloohms here, and you have 1 microfarad here. You have plus minus VC of T right here, like that, right? So basically, what you need to do, you need to find VC of t, which is basically VC of infinity, plus, but over here you don't have a VC of 0, but VC of 10 milliseconds, right? Minus VC of infinity. So basically, your VC of t is equal VC of infinity plus VC of 10 milliseconds minus VC of infinity times e to the minus t minus 10 milliseconds, because you have that delay, divided by tau 2. That's what's the difference, okay? We done that because you don't start at 0, you start at 10 milliseconds, therefore you have to put that delay there, right, of 10 milliseconds. So, what do you guys think? What's VC at infinity again? For that circuit? What's going to be VC at infinity?
0.
0 again, right? Because it's a natural. So this is also NRRC, right? Natural response of RC. And then so that means that VC at infinity is 0. How do you calculate VC at 10 milliseconds? How do you do that? What do you do? How do you do that? What would you do? Find VC at 10 milliseconds.
Plugged in.
Huh? What's that?
Plugged in.
This one, right?
Yeah.
Correct. So you plug it in there. There's going to be 80 times e to the minus 40 times 10 milliseconds, which basically gives you, when you do that, that turns out to be 53.63 volts. And then tau 2 is basically our Thevenin times C. Well, our Thevenin in this case is 25K in parallel with 100K. That gives you, when you calculate that, tau 2 is 20 milliseconds. And basically that gives you the VC of t, finally is equal to 53.63 e to the minus t minus 0.01 divided by 0.02 volts for t radical 10 milliseconds. Answer to part B. Like that. So as you can see, it's very similar to what we did on Monday, right? No big deal. Any questions? Any questions, friends?